Okay, hi and welcome to Note 7.6, which is a system of linear inequalities. So if yesterday you were with us, you noticed that we graphed a linear system. So we saw some kind of a line that we graphed, and then we talked about it being dashed or solid, and then we talked about shading one side or the other. Today what we're going to do is we're going to add another line to the mix. So really, we're going to be talking about a system, so two or more. We're really probably going to stick to the fact of two. And then shading two sides. And where the overlap is, and I'm just going to shade the overlap in this quick little example here. So where the overlap of the blue and the yellow there, that's the solution for both lines, or the system that we're talking about. So the solution falls in that system, that solution set there. So let me grab a pen. Let's jump down to the investigation here. We're not going to do the whole investigation, but let's just quickly note what it says. It says basically graph this inequality here, which is 3x plus 3y is less than 10. And then it says graph this inequality here, which is 5x plus 6y is greater than 9. If we did this in class, I'd have you put it in Desmos, and you can see that it's there because I don't want you to worry about graphing at this point, and graph it. And you would get an image like this here that you see on the board or on the screen here. And what you find out is similar to what we just discussed there, that the solution set is this overlapped area right here. And what does that mean? Like, how do you know that's the solution set? Well, if you wanted to check to see a solution set, you could pick any point here, and you can see I've picked a few right here. There's a couple of points. We'd plug those points in for both of these inequalities, and if they were true for both, then it is a solution. So let's go ahead and do that. I'm going to use this point 1, 1 because it looks pretty easy, right? So 3 times 1 plus 3 times 1 is less than 10. I'm pretty sure we can do that. 3 times 1 is 3, 3 times 1 is 3, 3 plus 3 is 6. So is 6 less than 10? Yep, that's true. So we're good there. Let's check the other one. So 5 times 1 plus 6 times 1 is greater than 9. So 5 and 6, right, make 11. 11 is greater than 9. So that's also true. So check. So that shows that it's a solution for both inequalities, which means it's part of the solution set. The only place you're going to find points that are true for both is in that overlap section. That's really what you're supposed to discover here in this investigation, that overlap section there. We could pick any other point here. You can see all the ones I've picked in green, notably 0, 0. And what you should find if you plug that particular point in, you can see that I wrote both equations here. I've plugged 0 in for it, and if you do a quick calculation, those all turn to 0. These all turn to 0, so you find 0 is less than 10. Well, that's false. And you find out the 0 is not greater than 9. Oh, sorry. 0 is less than 10, so that's true, but it's true for 1. So it works as a solution for this inequality, but not for this one. So while it works for one, and it doesn't work for another, it has to work for both to be a solution. Okay, and that's algebraically how you show that to be the case. So let's talk about the definition then. So two or more linear inequalities forms a system of inequalities, and a solution to this is the solution of a linear inequality makes each inequality in the system true. So it has to make everything each true. So what does that look like? Let's take a look at another example here. It says solve by graphing. So here's here's a system of linear inequalities. There's two inequalities. We've got y is greater than 2x minus 5, and we've got 3x plus 4 is less than 12. So graph however you choose. The first one I graphed by the fact that it's in slope-intercept form. So I went to -5. Here's -5 right there. And then my rise over my run, or my slope, is up 2 over 1. So I'm going to repeat that process. So continue up that pattern, up 2 over 1, and you can repeat those points as many times as you need to, and then you can obviously go the other way down to left 1. So do that, draw your line, there's your first one. Check, done with that first one. Now I'm going to go ahead and graph the other one on the same side. I probably should shade this one, but we'll do that after. Let me get through the graphing. So to graph this, what's in standard form, I'm going to go ahead and graph by the intercept method. You can change that form if you choose to. If you want to change it to slope-intercept form, you can. There's nothing wrong with that. So intercept method says I'm going to make a little table. I'm going to use 0 for my x-intercept as a y-coordinate and 0 for the x-coordinate for the y-intercept. So I've got those two. I'm going to plug in 0. 0 for the y, so I get 3x equals in this case 12, right? Because we don't want to treat that as an inequality because it is a coordinate point. And so go ahead and solve for that. I get 4, and then reverse that and plug in 0 for the x-coordinate, so I get 4y equals 12, and I get 3. So there's my two x-intercepts. You can see I've placed them here, and I go ahead and draw that line. Now let's go back in and talk about the inequalities themselves. So if we look at the first ones here, you'll notice that I actually don't have dashed lines. So I'm going to go back in and dash these. because this inequality here, I didn't say that, but if you look closely, does not have an equal sign underneath, and that was my first red line, so I'm going to go ahead and dash that line. And then if you look at the second one, it is also dashed. It does not have an equal sign, so I'm going to go in and dash this line as well. So that's the first part we got to pay attention to while graphing these, right? Graph the line, see if it's solid or dashed, and the third is we got to decide which side to shade. Those are the three things that we have to go through. Let me write that down just so you can review from the last notes. Graph. Okay, graph your boundary line. That's what we like to call it. 2 is see if it's solid or dashed. And then 3 is shade. Right, and decide which side it's shaded on. Well, the first line we look at here in slope-intercept form, it's easy to decide because it's in that nice form where we get to see the y and the inequality all isolated by itself. So this says the solutions, right? Y, that's how we refer to it. The solutions are greater than, because that's a greater than sign, greater than the line. So for this line, this red line, I'm going to shade above. So I'm shading this side here. Okay? So there's that shaded. Now I'm going to look at the other one. Notice that I can't tell that. And you can make an assumption, and some of you might be able to move these in your head and see what it is, but it's best to do a test point for this scenario. So pick a point. Again, I usually reference 0, 0 as your point because it's an easy one to do. Plug in 0 for x, which turns that whole thing to 0. Plug in 0 here because 4 times 0 is 0. So both of those turn to 0. Is 0 less than 12? Well, that's true. So I'm going to shade that side of my second line, and I'll even change my color here so you can see it. I'll make it black. So I'm going to shade this side. And the overlap, or in this case, this location here, I'll really get in on this. This is your solution set, this whole thing here. So any point in here is a solution, any of them. How about ones on the line? Let me see if I can pick another color. I know I've got this really heavily coated, so I'll pick a really large red dot. What about something on that line there, or something on this line here, or here? Are these solutions? No, they're not. Why? Because those lines are not included. Notice if they had an equal sign, then those would be included. Those would be part of the solution set. But because they're on a dash line, dash being the optimum word here, they are not part of the solution set. So anything else in that shaded region, not including the line, is part of the solution set. And if we plug those in, we would find true statements. If we picked one up here, we would find it's true for the red line, but not for the green line. And if we picked one down over here, we'd find that it's true for the green equation, but not the red equation. That's kind of how that goes. So let's do one together now that I've taken up some time. Again, this is kind of the same scenario. So we're going to graph this by slope-intercept. I'm going to go to +2, put my point. I'm actually going to probably zoom in a little bit here so I can see this a little more clearly. So I'm going to go ahead and put 2 in, and my slope then is a negative, which means a negative 1 over 1. So I'm going to go down 1, right 1, down 1, right 1. So I'm going to get a line that looks something like this. Again, I like to do lots of points. It makes for a much more accurate line. So there's my line. I'm going to notice that there's an equal sign, right? So step 1, graph, which we kind of have. Step 2, decide if it's solid or dashed. So it's going to be solid, so I'm going to draw a solid line through there. So there's my solid line. Step 3, I'm going to shade. This one again set up for us. Y, or the solutions, is greater than, that's a greater than sign, my line, my boundary line. So I'm going to shade above. I'm going to grab a little highlighter here. I'm going to shade above this line. I'll go down. There we go. So here's my shaded region. Let me clean that up because I can't handle the messiness. You guys can wait for a second, I suppose. All right, so there's the first one. Let's graph the other one in a different color. We'll choose red this time. This one's in a standard form, so I'm going to go ahead and do my little table here because I want you guys to get used to this. 0 for my y coordinate, 0 for my x coordinate. Let's go ahead and plug those in. So first, I'm going to plug 0 there. That whole thing turns to 0, so I get 2x equals 4. Divide by 2, so x equals 2. So my first coordinate is 2, 0. And then I'm going to go ahead and move that 0 and make this 0 now. So I get, and I'll come over here, 4y is equal to 4, so divide by 4. Divide by 4, y is equal to 1. So I get the point 0, 1. Let's plot those 2 points. 2, 0. There's our intersection point, how nice. And 0, 1. So it doesn't give us a lot of room here. It doesn't give us much of a line. You can see why more points are nice, but I'm going to go ahead and draw this in here. And I didn't check to see if it was solid or dashed. It should be dashed, so I'm going to erase this and I'm going to go back and dash it now. Okay, so that was step 2. Now I got a dashed line. Now I've got to decide which side it's shade on. Again, in standard form, I'm probably going to do a test point. So I'm going to label it so Mr. Hallam can find it if I'm doing this in my homework. Again, for the test point, I'm going to try to pick 0, 0. It is free. It's not covered, so I'm going to decide if I shade below or above right now. So my test point is 0, 0. 0 for 2x, that turns to 0. 0 for 4y, that turns to 0. And that's got to be less than 4. So is 0 less than 4? Yep, that's true. So we're going to shade that side. I'm going to write that out. There we go. So I'm going to shade the side test points on. It's below the line, so I'm going to go ahead and shade below. We'll pick a fancy green for this one. Oops, it didn't go very well there. So if I shade that whole bottom section, you get the idea. So the overlap, and I'll come back in with, I don't know, maybe purple or something. The overlap actually is this little section in between here. So any points in that that overlap section there is where your solution set will be. Does it ask us any more than that? No. We just kind of identify the solution set, and then we know to pick points from it. If you look at the blue line, if I pick points on the blue line, those would be part of the solution set. If I pick points on the red line, they would not. Any integers in here, I could plug back in and verify that it works for both. Any points over here is going to work for the red line, which is the second one, and any points up here will work for the first equation that we did, or the blue line, and then any points that I pick in here aren't going to work for either equation. They're neither solutions for, or they're not solutions for either one of those. Okay, I jumped over here to page 2. I paused the video and jumped over here. I'm going to do two more quick examples, one that I've got done for you, one we're going to do together. So now this asks us to write the system, and whenever you see write, that means you're writing the function for it, the inequality itself. So here's kind of the way that I go about this. I'm actually going to do the one with 3 lines on it first. There's 3 lines here. Here's one line that's green. Here's a line that I've marked as red. And here's a line that I've marked as this light blue. And the shaded region is obviously the overlap or the solution part of it. So that kind of tells you where you're shading. So you're shading in this direction on this line. You're shading up on the horizontal line. And you're shading left on the vertical line. Do you need to draw those arrows? No, I just put them in there to help you see it a little bit better. So what you want to do is first attempt to write these into slope-intercept form if you can, y equals mx plus b, because that's the form we're most familiar with. If that doesn't work, remember you can't write into standard form. So the other form you're going to write into is point slope form, which is y minus y1 equals slope times x minus x1. Now, preferably, you change that into slope-intercept because that's how your answer is going to be represented in the book. But if it doesn't say to, you technically don't have to. So with that in mind, let's see if we can find some information here. You can see that we did the first one here. This is the red one, so this is this line here I'm pointing at. I should probably change that to red just to keep consistent. So here's my red line. And I can see that my y-intercept is right there, so I mark it 0, 0. Can I identify my slope? Yep, you can see my slope's repeated, right? So it's up 1 over 1, up 1 over 1, up 1 over 1. So my slope is 1. So I'm pretty much done. The only thing I need to decide is 2 pieces of information. One, what's the inequality? And I've written all over it now. And if you look at that line, now that I've erased everything, it's solid. So it means I get an equal sign underneath. And then I've got to decide which way to shade. Well, the shading of this we already said was below. You can see my arrows that I marked here. So it's below. So solid and below. So I recorded all that information. It's nice. Now I can go down here and write, but let's grab the rest of the information. We'll talk about writing it from there. Let me clean this up a little bit. So the green line then, this horizontal line, is a special case. And we did talk about horizontal lines. Now the funny part is we've spent a couple of days graphing these on number lines, right? Where we put a 0, we put a 2, and then we graph and shade. Oops, that's supposed to be a 2, and then we shade for one side or the other. But sometimes with a special case, we do put these on coordinate planes. So if we're talking linear systems or if we're talking linear functions, you do need to put these ones that look like this, a y equals or a y is less than or greater than or than equal to, then you need to put those on the coordinate plane. So you will have vertical and horizontal lines. What you have to remember from this is that if it's a horizontal line, it goes through the, let me change this to green so I'm consistent with my colors here, it goes through the y-axis. So that means it's y equals 2. That's the linear form of this. We'll add the inequality in a minute, but let's check it again. It's a solid line and we're shading above, so we've got that there. The other special case here, and I'll switch my color to blue, is this line here, and you'll notice that it's dashed. Okay, it's a vertical line, so it goes through the x-axis, so it should be x equals whatever point it goes through, in this case 5. So it goes through x equals 5. It's dashed, so it doesn't get the equal sign underneath. And this one we're shading below, or the lower value, so it's a dashed and below. So let's write that into a function. or a system, shall I say. So if we look at the first one, my y-intercept is 0. I'll change to red so you can see that, right? Because we don't ever write 0, so plus 0, I'll put it on here. Well, it didn't change to red, but you get the idea. My slope is 1, so y is less than or equal to x plus 0, or y is less than or equal to x. So the second one, since we already know it's y equals 2, all we have to do is add the inequality. So we're just going to change that equal sign to a greater than or equal to sign. And for the x, the same thing. We already know what the equation looks like because it's a special case. Instead of the equal sign, we're going to change that to a less than sign. So this would be, this would be the system that represents that. And remember, this fancy bracket just identifies a solution set. That just means that here's the system. So let's do one from scratch. We'll go over here to the number 2 example, or the first example that we skipped over, A. So here it is. Again, I'm going to switch my colors to the red so we can talk about that. Here's the red line. I'm going to look to identify a y-intercept. You can see it there. It's 0, -2. Then I'm going to identify my slope. I'm up 1 over 1, up 1 over 1. So my slope then is +1. And I'm going to look to see that the line is dashed, so it's not getting an equal sign in it. I do need to identify how it's shaded. It seems to be shaded above, so I'm going to write above and dashed. Okay, so let's do the green line at this point. So the green line, if we look at this line, which is here, it was nice enough to give us a y-intercept. It looks like it's a y-intercept of 3, so I'm going to write 0, 3. My slope for this one looks like I'm down 1, 1, 2, 3. So down 1, right 3. That's my slope. And it's a solid line, so it gets an equal sign underneath. And my shading seems to be below, so I'm going to say below and solid. Got all the information I need, so I'm going to go ahead and attempt to write this system now. So for the red line, I'm going to change back to red for us. So I'm going to say y is greater than, which means shade above, not equal to because it's dash. I'm going to put my slope in, which is 1 or 1x, or just x, plus a -2 or -2. So if I clean that 1 out of there like I should have in the first place and remake that x, there's my first equation, or inequality, I should say. So let's go ahead and pick a green one, do the same thing again. Put my y. I'm going to put less than or equal to, because it's below and solid. I'm going to put my y-intercept, or I'm going to put my slope first, which is -1/3. I'm going to put my x, and then I'm going to put +3 for my y-intercept. And there's the system for my equation. All right, so I'm going to go ahead and skip over the word problem because I don't want to take any more time. You've got enough examples to be able to handle it. We'll talk about the word problem in class, and we'll see you there for examples.